A very good afternoon to everyone. Am I audible to you people? Let's begin with today's class. So, the topic of today is glycogen metabolism, right? So, we'll be talking about glycogen metabolism in detail along with the regulation. But before beginning with the class, as we say, that let's crack neat together. Topic of today is glycogen metabolism. Glycogen metabolism. Before beginning with the exact topic, let us have a small introduction about Unacademy. Unacademy is one of India's largest app or online portal for the preparation of NEET examination. These are some of the faculty members at Unacademy, and they are one of the best faculty members all over India. So, with the help of Unacademy, you can have the benefit of being mentored by the best faculty member all over India. Then there are special classes for the sneak peek, and what is so special about these classes is that you can ask your doubts directly with the faculty. Classes are live. So this is a very important thing because you can get your doubts and queries solved during the class itself. Then there are test series, and as I always say, whenever you want to prepare for any competitive examination or any um, examination in which there is multiple choice questions, then you need to know what is the pattern of the examination. What are the PYQs? That is also possible with Unacademy with the help. There are free mock tests, then weekly tests, and then you can anytime just go and watch the videos. And this is one of the easiest way to prepare for the examination because the flexibility of schedule is one thing. Language can be of your choice because there are many faculty members who are teaching languages. So language can be of your choice, and unlimited practice is the added benefit that once you have taken and retake the quiz, so unlimited practice, then you will feel like classroom. You won't feel anything because you can chat with your educator, you can have interactive, you can learn anytime, anywhere with the help of this Unacademy system. So how you can download the app? You can just go to and write Unacademy app, and you'll be seeing the logo of Unacademy app. Just download the app, make your account, and you're good to go. Then there is this plus subscription, and this plus subscription you can get all the 90 subjects, usually topic you can get. So this plus subscription can be very much beneficial for having the knowledge about the whole syllabus. Then this plus subscription, in this you need to pay a certain amount for getting subscription, and that is quite pocket friendly, 5,000 and for 1 month. Then if you're going for a longer duration of 12 months or 20 months, then the subscription charges are very less. And in this subscription charges also you can get a 10% discount if you use my referral, that is FB1. So for availing a 10% discount in subscription, just use my referral code, that is FB01. So still it is quite less, and by using my referral code it will be much lesser. So quickly now starting with the topic, that is glycogen metabolism. Glycogen metabolism. So before beginning with glycogen metabolism, let us understand some of the terms. And what are these terms used for? So the first term is glycogenesis. Glycogenesis. What is the meaning of glycogenesis? It means synthesis of glycogen from glucose. Synthesis of glycogen from glucose. Then second term is glycogenolysis. Glycogenolysis. Meaning of glycogenolysis is dissolution of glycogen to glucose. Dissolution of glycogen to glucose. And the two things that we will be studying in glycogen metabolism is glycogenesis, glycogenolysis, that is the formation of glycogen from glucose, and dissolution of glycogen into glucose. So these things we are going to talk in this. Then we are going to talk about regulation in class, that how it is regulated. So in regulation, we are going to talk about two hormones, that is insulin and glucagon, that how insulin is responsible for uh, regulation and how glucagon is regulated. And then we are also going to talk about disorders which are related to glycogen metabolism. Disorders. Disorders of glycogen metabolism. Right? So all these things we are going to talk in detail. So starting with glycogenesis. Glycogenesis. So it is made up of two terms, glyco and genesis. Glyco is for glycogen and genesis is formation. So when we are talking about formation of glycogen, we should know that what kind of polymer it is or what kind of molecule it is. So glycogen is a homopolymer of glucose. The homopolymer of glucose. Then if it is a homopolymer of glucose, so is it a linear chain or is it a branch chain polymer? When we are talking that it's a polymer, so it's a linear chain polymer, or is it a branch chain polymer? So it is a branch chain polymer. So if it is a branch chain polymer, so is it like what kind of bonds are there? So when we are talking about that it's a branch chain polymer, so it is made up of two types of linkages. For the linear molecule, for the linear molecule, the bonding is in the form of alpha 1,4 glycosidic linkage. Alpha 1,4 glycosidic linkage. And when we are saying that it's a branch molecule, then the linkage is which kind of linkage it is? It is alpha 1,6 glycosidic linkage. This alpha 1,6 glycosidic linkage. So for linear, it's alpha 1,4. For branch, it is alpha 1,6 linkage. Now, why does this branching occurs, or what is the need of this branching? What happens if it is a branch chain polymer? So if it is a branch chain polymer, what happens is that this branching is useful for making glycogen globular, useful for making it globular. Then second thing is that it makes it compact, so that now it is occupying less space. So branching is useful in case of making it globular and making it compact. So we are talking about glycogenesis, and glycogenesis means synthesis of glycogen from glucose. So what is the site? Where does this process actually occur? The place where it occurs. Site of synthesis, cytosol. Cytosol. And cytosol where exactly? Cytosol mainly of liver and muscle. Mainly cytosol of liver and muscle. Right? So if we are talking about glycogen synthesis, so what is the basic monomeric unit of glycogen? It is glucose. The monomeric unit of glycogen is glucose. So for formation of glycogen, we should have glucose molecule. The availability of glucose should be there. Glucose should be available. Should be available. Right. So whenever a person is in a very well-fed stage, whenever he has just consumed his food, so there will be synthesis of glycogen from glucose. So in well-fed stage, well-fed stage or state, glycogen synthesis will occur. Glycogen synthesis occurs whenever a person is well-fed. So moving ahead and talking about it, so starting from glucose, we are saying that glycogen is formed from glucose. So how is it formed? The glucose will get converted into glucose 6-phosphate, glucose 6-phosphate with the help of enzyme. Name of the enzyme which is responsible for this kind of reaction is glucokinase. Kinase is the enzyme. Then moving ahead, after glucose 6-phosphate, what will be formed? Glucose 1-phosphate. Glucose 1-phosphate. And the enzyme which is responsible for this kind of reaction is base. Then from glucose 1,6-phosphate there will be formation of UDP glucose. There will be formation of UDP glucose. And this whole thing, formation of UDP glucose from glucose, is called as activation of glucose. Called as activation of glucose. And this activation of glucose is the very first stage of glycogen synthesis, right? Then when UDP glucose is formed, the second step will come. So this will be continued further. We'll be taking another slide for further reaction. So we'll be doing it from UDP glucose. So now this is the very second stage of glycogen synthesis. So before actually moving towards the reaction, I need to tell you that for synthesis of glycogen primer is needed. Glycogen primer is needed. So what is this glycogen primer actually? It's a short molecule of glycogen. The short molecule, short molecule of glycogen. The short molecule of glycogen. So this short molecule of glycogen, how is it formed? This UDP glucose will further get converted with the help of glycogen synthase. The enzyme glycogen synthase will act. Glycogen synthase will act and form a chain of glucose with the help of glycogenin. Like this, glycogenin, and there will be addition of around, can say, 7 to 8 glucose molecules in the glycogenin. So glycogenin will attach with this the glucose which is coming from UDP glucose. So UDP glucose will change into this. So in this step there is addition of one glycogen or glycogenin by UDP glucose, or one glucose of UDP glucose is getting attached to glycogenin. So this step is called as initiation of glycogen synthesis. Second step, and it is called as initiation of glycogen the initiating phase. So in absence of glycogen primer, The glycogen primer, if it is absent, there is no glycogen primer, what will happen? There is another substance, this glycogenin. So we are always mostly talking in glycogenin only. Whenever we'll be studying about glycogen synthesis anywhere, it will be in terms of glycogenin. So whenever there will be absence of glycogen primer, there will be this glycogenin to take up the process. And this glycogenin, what is it actually? So talking about glycogenin, this glycogenin is a protein with oligosaccharide side chain. Is a protein protein with oligosaccharide oligosaccharide side chain. Can you see the oligosaccharide side chain? This side chain I'm talking about, right? And this extra G which I have written over here is coming from UDP glucose. One is coming from UDP glucose, and this is the side chain of the glycogenin. So in this step, what is happening? Glycogenin, it is getting attached with the UDP glucose, and this is how the glycogen primer is getting extended. In this step, there is addition of one glucose by UDP glucose, so there is lengthening of the glycogenin. So we can write lengthening of glycogen primer or glycogenin. Lengthening of glycogenin. So what will happen in the next steps? The next successive steps, what will happen? In the next successive steps, there is addition of glucose around 11 to 12 glucose will get attached in this step. So can say 11 to 12 glucose will successively attach in this step. So have learned about what is glycogenin, what is glycogen primer, then how the things are occurring. So this was the second step, that is the of glycogen of a second step, and the first step was activating glucose. Now moving towards the third step of the process. Third step is elongation. Third step of glycogen elongation is elongation. So what happens in elongation is glycogenin. Whenever this chain is approximately 11 to 12 glucose molecules long, there the 6 to 8 glucose they will get detached. They will attach it some other side and it will start branching. Okay, so the branching occurs in the elongation step. So right, for elongation we are talking about. So Saurav Best, who is the faculty of physiology on this channel. Saurav, you have to go through the channel and then only you will come to know. Okay, so elongation we are talking about. So this glycogenin will attach around 10 to 12 10 to 12 further glucose molecules. So this is the elongation step. Now after elongation, what comes is branching. The next step is branching. Now what happens in this branching? Whenever this particular length is obtained, whenever this particular length of glucose is obtained along with the glycogenin, some of the glucose molecules they will detach themselves, around 6 glucose molecules they'll detach themselves from this place, And when they will detach themselves from this place, what they will do, they will go and bind at some other place. And when these molecules will bind at some other place, they will initiate branching. What are they going to do? They are going to initiate branching. Fine. So let us see how it is occurring. So when the chain is around 11 to 12 glucose molecules long, 6 to 8 glucose, 6 to 8 glucose get detached and attach at another site and attach at a site, right? So this is the branching. So there must be some enzyme which is actually involved in this process. So the enzyme that is responsible for this reaction is branching enzyme, is the branching enzyme. Branching, fine. So branching enzyme is doing the things how, right? Glycogenin and how it will look like, and the molecules which have detached themselves around 6 to 8, they will come and attach like this. So this is the branch point. Branch point. Branch point. Let us just highlight this place. Branch point. Right? So glycogen along with the branching have obtained. Then after branching, the next step is elongation. Elongation. The next step is elongation. The fifth one is elongation. Right? So what will happen in elongation? The branching will continue and elongation will occur. There will be addition of more glucose. There will be branching. There will be addition of glucose and then branching. So glycogen is formed after elongation and branching. So elongation along with branching it occurs. Elongation and branching, they go hand in hand together. If there is elongation and there is enough elongation, it will just cut off the things and it will attach itself at some other place and it will lead into branching. So branching and branching and elongation will on occurring. Now in this process, the key enzyme of this process is glycogen synthase. Here, in the very first step, whenever there is formation of glycogenin, from the first step or addition of glycogen, that is the enzyme. Highlighter, glycogen synthase, the key enzyme of this process, and it is active in dephosphorylated steps. So that is very important to mention over here, that it is active in dephosphorylated step. Active in dephosphorylated state, right? So this is very important whenever you are talking about glycogen synthesis, right? So let us move further and let us talk about glycogenolysis. That is the next step in metabolism. Glycogenolysis. That is the breakdown of glycogen molecules. The place where it occurs is glycogenolysis, formation of glucose from glycogen. That is glycogenolysis. Site of this is cytosol. Site is cytosol and cytosol mainly of liver and muscle. Liver and muscle. So the end product here is glucose. End product is glucose. Now, how this process occurs or why it occurs: to provide glucose in middle of the meals, provides provides glucose in between meals, right? So whenever there will be around 12 to 18 hours of gap in the meals, the glycogen stored will start depleting after 12 to 18 hours. So after 12 to 18 hours of meals, glycogen reserve glycogen stored depletes, right? So this is glycogenolysis, and we are going to talk about glycogenolysis. So some more important things before moving actual step. Sorry, before moving into the actual steps, let us for moving into the actual process of glycogenolysis, let me just take some slides and we will see some important points regarding glycogenolysis, and then we will be further talking about the actual steps. Yeah. So the end product is glucose, that is the thing. So in muscle, also the end product is glucose, but it is in the form of glucose 6 phosphate. Liver, end product is glucose, and muscles, end product is glucose 6 phosphate, right? And why is this glucose 6 phosphate is the end product in muscles? Because in muscles, glucose 6 phosphatase is absent. Glucose 6 phosphate is absent, right? Understood? Now talking about the actual process of metabolism. So first of all, let us make a molecule of glycogen, starting from glycogenin. Then we'll be adding certain glucose molecules. So let us add around 12 to 15, right? And let us attach some of the branches also, right? Because glycogen is a branch molecule. So let us attach certain branch. So this is the branching point. And this linkage is alpha 1,6 linkage. Alpha 1,6 glycosidic linkage, right? And the linkage between these glucose molecules, they are alpha 1,6 glycosidic linkage. Alpha 1,6 glycosidic linkage. So now we are talking about breakdown of this. So here the key enzyme, like that the key enzyme was glycogen. Here the key enzyme is glycogen phosphorylase. Glycogen phosphorylase. Glycogen phosphorylase is the enzyme, and what is the function of glycogen phosphorylase? Is to move the glucose molecules successively from glycogen, and this glycogen phosphorylase PLP dependent, pyridoxal phosphate dependent, and it requires pyridoxal phosphate as a coenzyme, right? So there will be removal of what in this process? There will be removal of glucose 1-phosphate. Glucose 1-phosphate will further change glucose 6-phosphate isomer. So whenever there will be removal of these glucose molecules, what will happen? There will be formation of another thing which is called as or intermediate. Its name is limit dextrin. So removal of glucose molecules occurs till the formation of limit dextrin occurs. So let us make this. So there will be removal of glucose molecules, still formation of limit dextrin. And what is this limit dextrin actually? So let us take a highlighter. What is this limit dextrin? So whenever there are four glucose residues present on the either side of the branching point, it is called as limit dextrin. These are the four glucose residues. Here, these are the four glucose residues. So those residues are present at the branching point. The branching point. So this is the limit dextrin. Limit dextrin. So let us write what is limit dextrin. Whenever four glucose molecules or glucose residues on either side of branching point is present. Of branching point called as limit dextrin. Right? So branching point, and from here the four molecules are present, and this is called as limit dextrin. Now the key enzyme is glycogen phosphorylase, so don't forget it, and it requires PLP as coenzyme, right? So now talking about further in this thing, that as the linkage is alpha 1,6 glycosidic linkage at the branching point, action of glycogen phosphorylase stops. So let us write here, as glycogen phosphorylase comes near alpha 1,6 glycosidic linkage, its action stops. Action. So there must be some other enzyme. So it removes glucose one by one in the form of glucose 1-phosphate. Now, role of branching enzyme. Role of branching enzyme. Of branching enzyme. What is of branching enzyme? So this branching enzyme is actually a bifunctional enzyme. A bifunctional enzyme. So bifunctional enzyme means two activities it is performing. So first activity is transferase activity. First is transferase activities. Transferase activity. So it transfers the trisaccharide unit from the branching point to the linear molecule, right? So let me write this also. Transfers trisaccharides unit from branching point linear molecule. So how does he does this? Let us see actual reaction. That is glycogenin. Then there is certain molecules. Then there is this branch point, and from branch point there will be glycogen hanging, and here there will be 4 glucose hanging. So what this branching enzyme will do, it will remove disaccharides from the branching point, and it will bring it and it will attach it in the form of linear molecule. So this is after the branching enzyme. Now this site is free for glucosidase activity, which will act on it. So we can write now this site free for glycosidic or glycosidase activity for glycosidase, and it will act and it will act. So what will it do? It will remove the glucose from the branching point. So remove the glucose from branching point. So now what we will get is glycogenin with linear chain of glucose. We are going to get this. So here this is because of the action of glycosidase. 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 And there will be removal of this glucose molecule, specifically this molecule. That is the most important thing. And whenever this will be removed, formation of glycogen, there is formation of linear glycogen, right? Whenever linear glycogen form, there will be action of another enzyme, that is glycogen phosphorylase. Glycogen phosphorylase. There will be action of glycogen phosphorylase. So one by one, there will be removal of glucose molecule in the form of glucose 1-phosphate, 1 by 1, which is removed in form of 1-phosphate, and glucose 1-phosphate, 6-phosphate with the help of enzyme mutase, and glucose 1,6-phosphate, or there can be another fate of glucose 6-phosphate is it can undergo glycolysis for the production of energy. Can undergo glycolysis for energy generation. So now we have understood how the glycogenolysis. Let us have a very quick revision of glycogenolysis. So the site where it occurs is cytosol, and cytosol and muscle, and then we are going to say glycogenolysis. So it is glycogen and lysis, glycogen lysis or breakdown of glycogen. So it is a polymeric of glucose, definitely down into glucose, right? So it is required for the energy in the meals. It provides glucose or it provides energy between the meals. So whenever there will be a gap of 12 to 18 hours in fasting, there will be reduction in the glycogen stores in the Then in the liver, the end product of glycogenolysis goes, but in muscles, the end product is glucophosphate. And why is it so? Because in muscles, 6-phosphatase is absent. Now, how it is broken down, there will be formation of limit dextrin with the help of enzyme glycogen phosphorylase, and this limit dextrin is actually a molecule of glycogen. Whenever there will be no residue present on the either side of branching point, called as limited dextrin, right? And this glycogen phosphorylase enzyme of this whole reaction, and it is PLP dependent. So this glycogen phosphorylase, whenever it will come near the alpha 1,6, stop acting near that place. And then there will be the bifunctional enzyme, which is branching enzyme. First of its activity, transferase activity, that it will transfer goes from the branch to the linear molecule. And then there will be this glycosidase activity, that it will remove the branched glucose from its point to the linear molecule. And whenever it will, then glycogen phosphorylase will act again, and it will shorten the chain one by one by the production of one phosphate, which has got two phase, that is, it can get converted into phosphate and then into glucose, or it can be up in the generation of energy as well. Now talking about glycogen metabolism, regulation and disorder. So glycogen metabolism, regulation and disorders, right? So in this whole thing, we are going to talk about two important enzymes. We are going to talk about two important states, and we are going to talk about two hormones. Hormones, right? So talking about the two important enzymes, the two important enzymes is glycogen and the another enzyme is glycogen phosphorylase. Glycogen phosphorylase. So these two enzymes, we were saying that these two enzymes are the key enzymes. We have already talked about these, that glycogen and glycogen phosphorylase. So glycogen synthase, what is its function actually? What is the function of glycogen phosphorylase? Haven't we talked about them in detail? So the another important thing that we need to talk over here about glycogen phosphorylase is glycogen synthase. It is active in the dephosphorylated active phosphorylated state, and it is active in phosphorylated. So this we know about the enzyme. Then the two states, which I was saying that we talk about two states also. So the two states is dephosphorylated of the enzymes, phosphorylated state and phosphorylated. Then the two hormones which we have to discuss, hormones. What are the two hormones which we want to discuss is estrogen and glucagon, right? And epinephrine is also important. Epinephrine is also important, but the two hormones we are going to discuss is glucagon. So starting from insulin. So this insulin, it will actually favor glucose utilization. Will utilization. And if it will induce glucose utilization, means it level, level, right? Then glucagon. What will be its function? Function is will favor glucose formation or will improve glucose formation. Now, it is regulated by the hormonal mechanism, that is the allosteric mechanism, and there is role of calcium also in the glycogen metabolism. So let us see a pathway that how all these are actually related. So glucagon, what will happen? This glucagon will increase the cyclic AMP level. Cyclic AMP level. And whenever there will be increase in cyclic AMP level, will activate the protein kinase, will activate kinase, right? And phosphorylates the glycogen synthase. And whenever there will be phosphorylation of glycogen synthase, gene is inactivated. So there will be phosphorylation of glycogen synthase, the activated protein kinase will phosphorylate the glycogen synthase and it itself is inactivated. Itself will get inactivated, right? So this is how. So glucagon will perform this action in liver, perform this action in liver, and when we are talking about liver and muscle, both of the tissues, the hormone which will perform this activity is epinephrine. Epinephrine will do the thing in liver and muscle, right? So now we have this activated protein kinase and inactivated glycogen, question of glycogen. All next slide, activate protein kinase. Activate kinase. What is it going? Will phosphorylate the glycogen. Will phosphorylate glycogen. Phosphorylase and this glycogen phosphorylase is actually activated. Now activated because of the phosphorylation. Because of phosphorylation. So if it is activated, what is it going to do? It is going to convert glycogen to glucose and phosphate, the function of glycogen ligase. And this glucose is converted into glycogen with the help of glycogen, right? So, talking further, what is the use of insulin? Insulin will utilize the cyclic AMP here. In this page, you can see the cyclic AMP, right? The cyclic AMP will be utilized by insulin by phosphodiesterase, and it will further inactivate the downline reaction, and there will be inhibition of glycogenolysis, and the protein kinase is inactivated, and there will be dephosphorylation of glycogen synthase which is activated, and now the glucose is converted to glycogen. You can just see also. So how is it happening? That insulin will utilize the AMP by phosphodiesterase, and it will further inactivates downline reaction, and there will be inhibition of glycogenolysis, inhibition of glycogenolysis, and because of inhibition of glycogenolysis, protein kinase is activated, kinase activated, and there will be phosphorylation of glycogen which is activated of glycogen, and because of this there will be formation of glycogen from glucose, right? So have you people understood what is glycogenolysis and how is it regulated? Now moving a little further in the thing, that is what is the allosteric mechanism? So what will happen in allosteric mechanism? The glucose 6 phosphate will further lead into glycogenesis. So glucose 6 phosphate will stimulate and it will inhibit the glycogenolysis, will stimulate glycogenesis and inhibit glycogenolysis. This allosteric mechanism, right? First thing. Then what is the role of A and glucose phosphate? So talking about A, glucose and 6 phosphate. So these three, they will inhibit, all of these are going to inhibit glycogen phosphorylase. They will inhibit the glycogen phosphorylase. Was the second, and what is the role of A? and glucophosphate, and this mechanism that how glucophosphate it will support or will stimulate glycogenesis and how lysis. So ADP, glucose, and phosphate they will in phospholipase. Now talking about the role of calcium. Of calcium. So what is the role of calcium? Activates the phosphorylase kinase. Activates phosphorylase kinase, which in turn activates glycogen phosphorylase. Glycogen phosphorylase. Fine. So this was about of calcium that it activates phosphorylase kinase, activates phosphorylase kinase, activates glycogen phosphorylase. Talking about glycogen orders. So there are six important disorders that are related to glycogen. There is a very chronic health that is versatile player, Cori, Anderson. So we are going to talk about important disorders, talking about each one of them. Very first, for Von Gehr's disease. Von Gehr's disease. So in this disease, what happens is there is disease of there is of phosphate phosphate. The second disease, Pompe's disease, from people prayer. What happens in Pompe's disease? There is deficiency of lysosomal acid maltase. Deficiency of lysosomal maltase. Third one is Cori's disease. So what happens in Cori's disease? There are actually some other names for Cori's disease. That is extreme limit, and it is Forbes. Forbes. So what happens in this Cori's limit or Forbes disease? There will be deficiency of debranching branching enzyme. So the debranching enzyme, which is part of alpha 1,6 glycogen, right? Branching. Now talking about that is Anderson's disease. What will happen is that there will be branching time, branch time, and the enzyme which will four six transfer. Then fifth one is McArdle's disease. McArdle's disease. There will be deficiency of muscle glycogen phosphorylase. McArdle's. Then the last one is Hers disease. Hers. What happens in of liver glycogen phosphorylase deficiency of liver glycogen phosphorylase. Right? We have done glycogen metabolism, that is glycogenesis and glycogenolysis in detail. We have talked about enzymes, we have talked about the role of enzymes, role of hormones, then we have talked about the disorders which are related to glycogen metabolism. So with this there comes the lecture. Hope you people have understood what I have tried to do. So don't forget to subscribe to our channel, that is Acne. Also hit the bell icon for getting all the notifications. And lastly, use my referral code, that is FB, for getting an additional 10% discount in the subscription. Also go through my other videos related to biochemistry on the channel Let's Crack Neat. Go and watch those videos, like them, share them with your friends, and keep on studying. Also, do not forget to use my referral code, that is FB01, for getting an additional 10% discount. So this is it for today's class. We'll be meeting in some other class next in the next lecture.